Hi, I'm Andrew White, and I'm going to talk to you about the new self-piercing rivet connection type in Oasys Suite 18. First, a quick reminder of the benefits of the connection tool in Primer. The Connections tool allows the user to easily create, modify, and delete spot welds, bolts, adhesives, and other connections. The connection entity allows Primer to store all of the information that makes up the appropriate connection. That means that, for example, it is possible at any time to modify a connection easily, including updating and remaking it, and the associated information will also update accordingly. As Primer knows what entities make up the connection, it can also delete old entities and make new ones as required. Furthermore, the connection table, shown here, permits easy modification of many connections simultaneously. We have therefore tried to help improve workflows by allowing self-piercing rivets to be defined and modified via the connection tool also. Rivets are defined slightly differently to other connection types in LS-DYNA. They are defined through the constrained SPR2 card, which can be seen here. Rather than defining the actual geometry in terms of solids and beams as you would for a spot weld, say, rivets are defined just through a location in space via the node set ID field, NSID, and the other parameters listed in this card. Since they are defined through a node set, many rivets can be defined on one card. Because of these differences between rivets and other connection types, the connection tool for rivets is similar to, but not exactly the same as, that for the other connection types. I will now explain the similarities and necessary differences. The new features described in this presentation should make the use of rivets and constrained SPR much easier and improve associated workflows. In particular, rivets can be created, read, and written in a similar way to other connection types like spot welds. They can also be viewed in the connection table and modified from there. In the following slides, I will show examples of this. It should also be noted that SPRs can be read from and written to XML files and accessed via JavaScript. A rivet is created via the new SPR2 rivet connection type. The creation methods are similar to those that are available for other spot weld connection types, namely screen picking, node pick, nodes in set, lines of rivets, or geometry points. When rivets are created, the coordinates of the node or screen point chosen determines which layers will be joined. It is also possible to name the rivet connections using the optional title field on the Docked Connections panel. This can be useful to distinguish different rivet types. There are further options: match existing, create new SPR2, and select SPR2, which control how newly created rivets relate to constrained SPR2 cards. Using the match existing option, Primer will attempt to match the current settings to an existing constrained SPR2 card. If one is found, the new rivet will use that definition. If a match is not found, it will create a new SPR2 definition as per the Create New SPR2 option. The Select SPR2 option will only make the rivet if layers match between the connection being created and the selected constrained SPR2. A Use Preference Values option is available. This will use the values stored in the preference for the corresponding fields on newly created constrained SPR2 cards. The preference supports all those fields as shown on the constrained SPR2 card. The values can be modified post-creation using the keyword editor for selected constrained SPR2s. It is important to note that rivet orientation is important. In order to help with this, a button has been added to reverse the orientation of the last created rivet, if desired. The model shown contains some existing rivets. They are grouped under 3 distinct constrained SPR2 cards, as some have different diameters and some connect different layers. I will now create some rivets connecting the yellow panel A, part 100, and the red panel D, part 105. I will use a diameter of 10 and the option that will attempt to match existing newly created rivets to an existing SPR2 card. For the next rivet, I'm going to use the preference values, which also has a diameter of 10, but some other different settings. If I now look at the connection table, I can see that the first new connection has the same ID, 3, as an existing SPR2 card, as all the fields were identical. The next rivet, however, has required a new constrained SPR2 card, as other fields were different. This can also be seen in the constrained SPR2 keyword editor. Now, I'll create some connections using the Create New SPR2 option. Again, I'll connect parts 100 and 105, and I will use a diameter of 10. I'll just create the rivets along the top here. And for the last rivet, I'm going to reverse the orientation. If I go to the connections table now, you can see that they have been given unique new SPR2 IDs, and that the last rivet has the layers reversed. A quick demo of modifying rivets. First, note that there are 3 constrained SPR2 cards defined in this model, with IDs 2, 3, and 4. Each has more than one rivet defined within it. So if I try and edit some of the SPR data on just one rivet, I am prevented from doing so, as it could potentially edit other rivets I might not want to change. If I do want to change all the data for rivets associated with this ID, I select them all, then I am permitted to edit the data. Similarly, if I want to edit the layers, I need to select all rivets. Now I can reverse the layers, for example. If I want to edit just one of a group of rivets, I can split out the rivet required and then edit it. Now I've split this out, I can go ahead and delete one of the layers, for example. This also requires an update and remake. Note that editing coordinates does not require unique selection. So I can edit the coordinates on this connection without having to select all the rivets in this constrained SPR2 definition. This also requires an update and remake. Rivets can be written to XML files in a similar way to other connection types. The default option is to write the associated constrained SPR2 data also. However, it is possible to just write the node set ID if, for example, re-importing into a different model containing different SPR2 data. Similar settings exist when reading Rivet connections from XML files. In summary, rivets can now be created in a similar way to other connection types. They can be modified via the connection table, and they can be read from and written to XML files. They can also be accessed via JavaScript. A JavaScript example is given in the What's New document available from within the software. Thank you for your attention. Please check out our other presentations and do not hesitate to contact us for more information.